Good day, grade 12 learners. Welcome to today's physical science lesson. My name is Mashudu Mamburu. This lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. Today we'll be revising physics, that is physical sciences, paper 1. The topics is your mechanics, Doppler effect, electricity, and magnetism. Hoping you have some notebook somewhere where you'll be writing. You have your calculator where you will be doing some of these calculations. We'll be focusing mostly on exam skills to ensure that you are able to go there and write exams and pass. If you can look at topics for paper 1, end of the year, we have mechanics, which is 65 marks, wave, sound, and light, which is our Doppler effect with 15 marks, electricity and magnetism with 55 marks, matter and materials with 15. So if you can check in terms of these topics, mechanics, we have it for term 2. Wave, sound, and light, we have it. Electricity and magnetism, we had it as well in terms of the paper that you are going to write. And then it is still out of 150 marks, paper 1. We will still have our 10 multiple choice questions, which carries 13% of your paper, which is 20 marks. And we'll have your structured questions, which carries 130 marks. The total is still 150 for 3 hours. I always say this when I'm talking to learners to say 3 hours is 180 minutes, meaning that you have 150 marks for 180 minutes. If you do your maths correctly there, the division of 180 minutes by 150 marks, you will see that you have 1.2 minutes for every mark. So time yourself there to ensure that you don't spend much time on one content and end up not finishing the whole paper. So if you find that the question you are having a problem with, you pass to the next, then you will definitely come back and then we'll talk about all these exam skills as we go on. Now, let's look at last year, 2024, June paper. The June paper in 2024, we had the same topics, which is your mechanics. Remember, when we say mechanics, you are talking to your Newton's laws of motion, Newton's law of universal gravitation. We are talking to your Doppler effect in terms of wave, sound, and light. We're talking of electricity. We're talking of electrostatics. So under mechanics is all those topics, which is the first one. We're saying Newton's laws of motion, Newton's law for universal gravitation. You are having your momentum. You are having your vertical projectile motion. You are having your work, energy, and power. So those 5 very much important that you know that when you say mechanics, we're referring to those topics that you will be getting in your paper. And then we are saying wave, sound, and light, you have Doppler effect, you have electricity, you have electrostatics. So those are the topics. Last year's paper, question 2, it was Newton's law of motions with 22 marks. And there it was integrated with equations of motions or impulse. So there will be some integration with these questions. Don't expect that if a question is on momentum, it will only be momentum. It can be momentum integrated with mechanical energy like we had last year. So you have to check. Question 3, it was Newton's law of universal gravitation with 10 marks. Question 4, it was vertical projectile motion with 19 marks. Question 5, it was momentum. That question was integrated with mechanical energy. Now, question 6, it was work, energy, and power. Question 7 was Doppler effect. Question 8 was electrostatics. Question 9 was electricity, just for 8 marks. But this year, electricity is including internal resistance. So it's very much important to know that even the marks might be more for this particular question because now we have internal resistance as well. Last year, the paper didn't have internal resistance, but now I hope you have revised your internal resistance and we are going to do internal resistance in this lesson to remind you of what we are talking about. Now, in terms of your scope or the format of our question paper for 2025, I hope you receive this scope or this format of this question paper that you're going to write for June 2025. Our paper, it will still have 10 multiple choice questions, which is 20 marks. So I hope you have trained yourself in terms of skills of how to answer multiple choice questions. And then we will have 20 structured questions we'll have structured questions with 130 marks. So you can see multiple choice 20 marks, structured questions 130. You add them together, 150 marks. So I think multiple choice is important as well. Hence, I always emphasize that you can't leave a multiple choice question unanswered. You will put something A, B, C, or D there. You can't leave it open because you are losing those 2 marks per question. So it's important that you take multiple choice questions as important as well. Now you're going to spend 3 hours in your paper, and then mechanics 100 marks. So a lot of marks will come from these topics. We said it's Newton's laws of motion, Newton's law for universal gravitation. We said it's momentum, it's vertical projectile motion, it's your work, energy, and power. So these 5 topics, you are expecting to get 100 marks from those topics. Wave, sound, and light, which is our Doppler effect, 15 marks. And then electricity and magnetism, which is your current, electricity, and your electrostatics, will have 35 marks. So that is your scope. As you revise, you will have that in mind to say, this is what I must do. Some will say, I will start from what I know, which is maybe Doppler effect. You do it, you ensure that you understand everything about it. You move to other sections where you're going to spend even much of your time. So you must be able to time your revision program so that you are able to revise everything. And then for this lesson, we allocated 90 minutes. So we're going to have 90 minutes, and we'll try to ensure that we move and finish this lesson. And we're saying much of our time will be spent on mechanics. We are budgeting about 60 minutes on mechanics, 9 minutes on Doppler effect, and 21 minutes on electricity and magnetism. We'll see as we roll our program that it allows us to try and work around that. Now, when it comes to Newton's laws of motion and forces, remember, we're talking about Newton's first law, Newton's second law, and Newton's third law. The fourth one we said is Newton's law of universal gravitation. So you will have to know all of those. Newton 1, 2, 3. All of them, you have to know them. And you know that for Newton's first law, we're saying F net equals to 0 newtons. What does it mean, F net equals to 0 newtons? It means a body is remaining, an object is remaining at rest. When an object is at rest, we're saying there is no acceleration, hence we're saying F net equals to 0. So we're saying if an object remains at rest or moving at constant velocity unless acted upon by an external resultant force. So we are saying always remind yourselves of these definitions, or how to state Newton's first law. To remind yourself, know that this one, F net equals to 0 newtons. Why is it 0? We're saying a body remain at rest, which means acceleration is 0, or the body is moving with constant velocity. I want you to have an understanding that when we say constant velocity, we're saying that the final velocity and the initial velocity are equal. So if you are to find the change in velocity there to calculate acceleration, because you are reminding yourself that acceleration is the rate of change in velocity. So if the change in velocity is 0, definitely acceleration will be 0, and our F net will be equals to 0 newtons. So have that understanding to say a body will remain at rest or moving at constant velocity unless acted upon by an external resultant force, which is where the Newton's second law starts. Remember, with Newton's second law, we're saying F net equals to ma, which is saying now when a net force is applied on an object, the object will accelerate in the direction of the net force. And you are saying acceleration is directly proportional to the net force, and acceleration is inversely proportional to the mass of the object. So it's very much important that you know and understand Newton's second law as well, and you will be doing application of these laws in terms of questions that will be given, and then you will be able to apply the law and do your calculations. And we have Newton's third law, which was saying when body A exerts a force on body B will exert an equal but opposite force on body A. So we are saying remind yourself of all these laws before you go for your exams, and you will be able to do well. Now, how do you solve problems that include based on Newton's laws of motion? We are saying in application of Newton's laws, the following are important. The first important thing is that let's be able to identify the forces acting on the object. How do you identify the force? You must be able to draw the free body diagram or force diagram. The free body diagram or force diagram. Now, I'll just talk to you small mistakes that learners make in terms of drawing the free body diagrams and the force diagrams so that at least you don't lose those marks of free body diagrams. Remember, you're expecting this mark when you're dealing with Newton's laws of motion and when you're dealing with work, energy, and power. And sometimes, even when you're dealing with electrostatics, you'll be asked to draw those free body diagrams. So it's important that you have all this knowledge and you are able to use it when you deal with these questions. When you are dealing with the rough surface, for example, rough surface is referring to friction. So it means we have friction. But when we say smooth surface, we are saying this surface is frictionless. Frictionless, smooth surface. Rough surface, it means we have friction. And we are saying pay careful attention to the mark allocation. If you are given 3 marks, for example, it means it's just a routine calculations where you just write your formula, substitution, and your answer. So we're saying pay attention to direction for vectors. Hence, we are always emphasizing the FSAUD, which we're saying is the formula, is the substitution. You write the answer with the correct SI unit and direction. You only write direction if you are dealing with vectors. So never leave any question that says calculate an answer, because all you have to do, identify the formula, substitute on that formula so that you are able to mark you all that. So every question that says calculate, every learner will respond to it because they will have to identify the formula, they will have to substitute on that particular formula, and that will definitely come handy to us as we prepare for these exams. The data sheet, this is where you get a lot of information. Remember, we talked about Newton's first law. We said F net equals to 0. So this data sheet is able to remind you of that, to say a body is remaining at rest, hence the acceleration is 0 there. Hence we're saying F net equals to 0 Newton for Newton first law. But for Newton's second law, we said F net equals to ma. So what does it mean? We said when a net force is applied on the object will accelerate in the direction of the net force. And then we said acceleration is directly proportional to the net force and inversely proportional to the mass there. So important, the data sheet always gives you information. Look at the momentum there. You are able to see your momentum, which is the product of your mass and your velocity. And then we are having our maximum static friction. Which is the coefficient of static friction multiplied by the normal force. So it's very much important when you get a question that you are given the coefficient of static friction, you are able to calculate the maximum static friction or your kinetic friction if you are given the coefficient of kinetic friction. So it's very much important to be able to utilize these formulas, and then you will continue to practice questions that needs you to use them. And we are saying here it is maximum static friction because this is when a force is applied on the object but the object does not move. We say that object has a maximum static friction. And then you will see when we continue with forces, the same formula under forces, it will be able to help us with impulse, which is the product of the net force and the time taken when that force is acting on that object. So the data sheet is important, and of much importance is the Newton's law for universal gravitation there. You have forgotten it, you are able to see every other particle will exert a force of attraction or repulsion directly proportional to the product of the masses and inversely proportional to the square of the distance between them. So this data sheet will definitely going to help you when you have to remind yourself. You have to remind yourself of definition or some of the laws that you need to state. You will go to the data sheet and it will definitely help you in terms of that. Now, with no waste of time, we're going straight to questions. We'll start with our multiple choice questions. This one was taken from November 2023. The question was 1.1 there. a constant net force is applied to a block, which one of the following statement is correct? So you know which law talks about a force applied on an object. You know Newton's second law. We said when a net force is applied on an object, the object will accelerate in the direction of the force. So you are able to locate the law that applies to a question, and then it helps you to answer that particular question. And then you see there that the block will move with a constant acceleration, which is option number B, and then you are able to collect to get your answer there. Now let's look at 1.2. It says a crate of mass m is stationary. Very much important to know that this crate is not moving, it is stationary on a plane inclined at an angle theta. You are having the angle theta there with the horizontal. Which one of the following statements regarding the magnitude of the frictional force? Please underline keywords there so that you know that we're talking about the frictional force acting on the crate is correct. So whatever the statement, which one is correct about frictional force? So the keyword there is frictional force, because you want to know frictional force. When you read these options, you must start with frictional force so that you understand the question. So when you go to option A, you'll say frictional force is equal to the component of the weight of the crate which is parallel to the plane, is larger than the component of the weight of the crate which is parallel to the plane, is equal to the component of the weight of the crate which is perpendicular to the plane. And the last option which says is larger than the component of the weight of the crate which is perpendicular to the plane. Now, what is the expectation here? The expectation that you are having, you know that you have to first draw the free body diagram. It always helps to draw free body diagram for that object. You are able to see that, okay, we're having our FG there, which is always towards the center of the earth, and we're having our normal force there. But now you know that your normal force must be 90 degrees to the surface at all times. So if my surface is like that, when I draw the normal force, I will draw it like that. So always be careful and always check that your normal force makes an angle of 90 degrees with the surface, because it's always perpendicular to the surface. But when it comes to FG now, it's always towards the center of the earth. So we must draw it going straight down there. Now, by so doing, already you know that this FG is at an angle, so you have to resolve it into its components, which means now your FG, you're going to have your FG parallel and your FG perpendicular. So very much important that your force is FG parallel and FG perpendicular. You have your normal force there. Now, this object FG parallel is acting downwards. It's pulling the object down. But we're told that the object is what? Is stationary, which means that the friction here, the friction now that is opposing the motion of that object, which is our static friction that we talked about, now is equals to FG parallel. Remember, these are balanced forces. Remember Newton's first law. We said the body will remain at rest. The body will remain at rest unless acted upon by an external resultant force. So it means here F net equals to 0. There is no forces that because the forces are balanced. The static friction and the FG parallel, they are balanced. Hence we are saying frictional force is equal to the component of weight of the crate which is parallel to the plane, which is FG parallel. So the frictional force, our static frictional force, is equals to component of weight of the crate which is parallel to the plane. So you're able to apply the Newton's first law, and you're able to get A as your correct option. Now I hope that helps you, and always it tells you that when you get question, always think about the law that is applicable to that particular question, so that you have the right understanding. Now we're having here two blocks, which is question 2. We have two blocks of mass 4 kg and 9 kg. So you can see the two blocks there are connected by a light inextensible string. The blocks are held at rest on a plane that is inclined at an angle of 35 degrees with the horizontal. A constant force acting parallel to the plane is applied to the block B. So there is a force. Now, remember, they were stationary. Now the force is being applied. This force is being applied on B, as shown in the diagram below. The blocks now accelerate. They are no longer stationary. The blocks, all of them, A and B, they now accelerate up the plane at 2 meters per second squared. So data collection is everything when it comes to physics. Without you collecting data, you're going to have problem, because already we know the acceleration now is equals to 2 meters per second squared. And we know that we have two blocks, the 9 kg block and the 4 kg block. You must be careful here. When you answer questions, you must know whether we are talking about block A or block B, so that you use the correct the mass of the asked or intended question that the question is asking about. So we are having the 4 kg block and the 9 kg block. When you answer questions, always know whether you're going to apply Newton's second law on block A or block B. And we are always advising you here to say, let's not use the body system. Instead, apply Newton's second law on each of the two bodies separately. Now, the first question here was, state Newton's second law of motion in weights. So you got to know all these Newton's laws of motion. So this one, we are saying that now, we said that when a net force, because we said F net equals to ma, or F net equals to ma, for you not to forget, we are saying that now, when a net force is applied on an object, again, the object has a mass. So you can see that a net force is applied on an object, the object will do what? Will accelerate in the direction of the net force. And we are saying acceleration is directly proportional to the net force, and acceleration is inversely proportional to mass. So you must be able to say all that for you to be 2 marks richer. So I hope all the questions that say state the law, we are well to do, you are ready. Now, the kinetic frictional forces acting on blocks A and blocks B are 5,88 newtons and 13,23 newtons. Data collection, as I indicated, most important thing, because you see statements that are written like this one. It's easy for you to omit them when you are answering questions, and immediately when you don't include them in your answering of the question, we're going to lose marks. So it's important that you ensure that you are able now to deal with that as well. You are able to know that I'm moving with 5,88 and 13,23, which are the kinetic frictional force for A and B respectively. Respectively means 5,88 is for A, 13,23 is for B. Now, the question says, draw a labeled free body diagram showing all forces on block A. As I indicated, always don't make a mistake. Know which block we are talking about. In this case, we're talking about block A, which is our block here. And then there is friction. So you know that the forces that are acting will definitely have a frictional force, will definitely have a tension on the string. Remember, the force that is acting on that string is tension or tensional force. So we'll definitely have our tensional force, we'll have our frictional force, and we'll have the force that we always have. Remember, Fg. As long as you're drawing free body diagram, Fg will always be there, straight to the center of the earth. So you must be able to draw your Fg, your tensional force, your friction, and your normal force. Remember, we only have normal force when we have the surface, because we're saying normal force is always perpendicular to the surface. I hope you got that, and it will help you when you deal with this question, as well as work energy and power. And with no any problem for 4 marks, you are able to draw your tension, your frictional force, your weight, or your Fg, as well as the normal force. Remember, normal force we're saying is always perpendicular to the surface, must always make an angle of 90 degrees with the surface. Now, you have drawn that, you've got your 6 marks already by writing your definition, by drawing the correct free body diagram. As we continue the question, it says calculate the magnitude of the tension in the string and calculate the magnitude of the force F. So you can see loaded 2 questions there to do. The most important thing, don't forget, we talked about those 2, which is now the kinetic friction of A and the kinetic friction of B, which we said is 5,88. And then if I can go back so that you are able to see that, it's 5,88 and 13,23. So as you move, you got to move with that. Say for A is 5,88 and 13,23 newtons for kinetic friction for B, so that you have no problem as you try to answer this question that want you to calculate the tension. Now, that is your object now that you are having. Remember now, we said you're applying Newton's second law on each of the objects separately. You have already drawn your free body diagram. So you can see that where the object is moving, we're going to concentrate on the forces. These forces, these 2 forces, that is where, because the object is moving in that direction, and then we know that the component of weight Fg, perpendicular and normal force are equal anyway, then they are going to cancel one another. Then our focus are the forces that are acting this way, which in this case will have the Fg parallel. Remember, on an incline, we must be able to, Fg must be have components. Now we must be able to deal with the components, which is the Fg parallel that we're going to focus on, and the friction as well as the tension. So you can see the 3 forces that are going to be involved when you do apply your F net equals to Ma. Remember, we said you're going to apply your F net equals to Ma for each object. So if you are dealing with block A, you will deal with block A. If you don't get an answer, you'll go and apply F net equals to Ma on block B, and then you will be able to use simultaneous equation after that. But don't use a body system. And then with no any problem, I hope I have explained and you have understood and you have identified the forces here. We said is tension, is positive, is going where the object is going. And the ones that are opposing motion, we had our kinetic friction and we had our Fg parallel. And we were told that this is equal to Ma. So what is left is just to dress that formula with the values that we have, and then we are able to calculate our tension. And with no problem, you can be able to do it this way. I hope you will continue to practice the question when you have written all the tension, the kinetic friction, and the parallel component of weight equals to Ma. All you have to do is to do the substitution, which is your kinetic friction 5,88, your mass was 4, G is 9,8, sine 35, 4 times 2 gives you 8. And then you are able to calculate your tension, which is 36 newtons. You can use up the incline as positive. You can use down the incline as positive. It doesn't matter. But most of the time, we always encourage learners where the object is going to take that as a positive direction. It just makes life much easier. And then you are able to calculate your tension, which is option number 1 there. But as well, if you use the second option, you are able to get the question. So I hope you will do as many questions as possible using this type of method. And then for the second question, which was F, you know F was the force that is acting on body B or on block B. So you are able to go to block B, and as well the free body diagram for block B is important there, because you must be able to indicate that we're having the force that is acting on that block, and then that is the force. And then what are other forces? Because we need to identify all the forces. We have the tension that is opposing, so it will be negative T. You have the F that is going where the object is going, sorry. And then you have your tension that is opposing the motion. On the strain, you are having your kinetic friction as well, and you are having the component now as well of weight. Hence, you will have 4 now, 4 forces that we are having, because it's Fg parallel, is kinetic friction, is the tension. All those 3, you can see they are opposing the applied force. They are going in the other direction. Hence, when you write them, you will write them as negative. All of them, they are opposing the motion, and that is equals to Ma. And once you have done that, what is left is just to plug the values that we are having, and then you are able to do that, and you calculate your force to be 118,18 newtons. But look at this statement here. It says, note if the system approach is used, 1 mark only will be awarded. So you'll get 1 if you apply, you use the system approach. Hence, we are saying apply F net equals to MA on block A as we did for 2.3.1. Apply F net equals to MA on block B as we did for 2.3.2, which is calculation of the force that was being applied there. So I hope this will help you, and you'll continue to practice these questions and make sure that when you write, always you write the right answer and then you write the correct SI unit. So now that was our Newton's law of motion. Hoping that as you go now to practice, there are things that already you have. The first thing, we've emphasized the laws to say know all the laws, be able to remind yourself of Newton's first law, Newton's second law, Newton's law for universal gravitation, Newton's third law. All those 4 laws, have them in your mind, state them, be able to state them. As you are dealing with the equation, be able to identify which law applies here. When like in the question we're doing, they said a force is applied on the object. Already you see that Newton's second law will apply. Now, with no any waste of time, we'll move to vertical projectile motion. What is important under this topic? Because that's what we are emphasizing today, to say this is the most important thing, that you cannot go tomorrow and write exam without knowing. The first thing, you must be able to explain what is meant by a projectile. What is meant by a projectile? So it's an explanation. So when you say this is a projectile, we're saying this is an object, like an object I'm holding here, an object that has been given initial velocity. So if I give this object initial velocity, I give it initial velocity, it starts to move, and then it moves under the influence of gravitational force only. So it means there are 2 conditions for a projectile. The first one is that the object must be given initial velocity. The second condition is that the only force that must be acting on this object must be the force of gravity, or the gravitational force only. So we're saying a projectile is an object which has been given an initial velocity and then it moves under the influence of gravitational force only. Please remind yourself the second definition, most important, which is the second part of the projectile, is to define free fall. Free fall is not an object. Remember projectile? We said it's an object, but when it comes to free fall, we're saying free fall is motion. Free fall is what? Motion, during which the only force acting on an object is the gravitational force. So you can see that a projectile undergoes free fall, because immediately when you give a projectile initial velocity, the only force, if the only force that is acting on it is the force of gravity, then we call it a projectile. So there are 2 conditions for a projectile. It is that the object must be given initial velocity, and the only force that must be acting on that object must be the gravitational force only. And then free fall, we're saying, is a motion in which the only force acting on an object is the gravitational force. So you can't go and write without having that understanding. And then the other important thing, we must be able to use the equations of motion to determine the position, velocity, and displacement. And then you have all these from your exam guideline. You must know how to sketch the graph. And we're saying here, we're saying position versus time graph, velocity versus time graph, acceleration versus time graph. So all those graphs, you must know how to sketch them. And we're talking about a graph for a free-falling object, for an object that has been thrown vertical upwards, for an object that has been thrown vertically downwards, as well as the bouncing ball. So we restrict ourselves to the bouncing ball. So the object we're using there is the ball, and then that is the object that we talk about. And then when you are given the graphs, you must be able to determine the position, the displacement, and the velocity or acceleration at any given time. Even for the graphs, you must be able to describe the motion of the object, either the bouncing, thrown vertical upwards, or thrown vertically downwards. So it's important that you have your graph skill on this one. Already, I've emphasized the definition of a projectile, which we said is an object that has been given initial velocity, and the only force that is acting upon it is the gravitational force. And we're saying free fall is the motion during which the only force acting on an object is the gravitational force. And I've emphasized that you must be able to know how to sketch the graph and how to determine the values or describe the motion of the graph. Now, the four equations of motion that we use is Vf equals to Vi A delta T. All those formulas, I know that by now you are aware of them. But we are saying when you come to this formula, you don't come empty-handed. You come to this data sheet rich with what? With data collection. You can't come here without data collection because it is only the data that is going to tell you which formula is relevant for the calculation that you want to deal with. So it's important that as you come to the data sheet, you come with the data. Now, when it comes to vertical projectile motion, we want to emphasize here to say always draw the trajectory followed by the projectile. When the projectile, if I'm projecting this object upwards and then it comes back to the thrower's hand, be able to now draw the trajectory, follow, see what is happening. Because immediately when you do that, you are able now to put critical points in your trajectory. For example, if an object is thrown from A there, be able to draw that it is thrown from A, which means it has initial velocity, is thrown from A, it goes to B, which means it reaches maximum height. We said it stops momentarily there. They be able to have that knowledge to say the object is going to stop momentarily, which means you know the final velocity. Already you can see that between A and B, you can make as many calculations as you want because we are having 5 variables that we can talk about only between A and B. So it's very much important that you put these critical points in your trajectory as you draw. Put the critical points. And we are saying show the point of launch, which is your A there, where you are launching your projectile, and show the maximum height, because you know the maximum height that the velocity there is 0 meters per second. Show the point, symmetrical point of launch, speed. What does it mean? It means if initial velocity there is 10 meters per second, then the velocity at C will be 10 meters per second in a different direction, which means based on your choice of directions, you would be able to say if A is positive 10, C will be negative 10, but the velocity is the same. It becomes the same. That's why we're calling it is a symmetrical point. It's a symmetrical point, which means there is velocity symmetry and then there is time symmetry as well. What are we talking about here? We're talking about time. Time from A to B will be equal or the same as time from B to C. So if we know time from A to B, you are as good as knowing time from B to C because you can simply multiply that time by 2. And then another thing, we're saying choose the sign convention. As I was indicating, you will choose that upward is positive. Immediately when you say upward is positive, as long as the object is going up, you are saying G is negative because G, gravitational acceleration, is always 9.8 meters per second squared downwards. I know you must be able to move with that. And then we're saying points of symmetry, we talked about them, the time symmetry and the velocity symmetry. This is the information that will help you as you solve the problem. The G is constant, 9.8 meters per second squared downwards. And always consider motion between any 2 points. So we're saying this animal that we are dealing with is big. Eat it piece by piece. If you are calculating between A and B, between B and C, between C and G, it just becomes easy. So always do data collection, but we are saying always consider motion between any 2 points. So there must be 2 points, and I'm going to use these 2 points to do my calculations. Then you are able to answer. I've emphasized this to say always focus on the formula. Substitution. You cannot substitute until you have done data collection. I think you know now by now that I'm emphasizing the issue of collecting your data because you must be able to dress your formula. You dress it with information that you have taken from the statement, from the given information, and you must be able to write your answer. And this answer must have a correct SI unit and direction. Direction applies to vector. As you are dealing with vectors, definitely you'll have that. And for your data collection, we're saying there are always 5 variables in terms of the equations of motion. Always check initial velocity, final velocity, acceleration, which is equals to g, which is 9.8 meters per second squared downwards. And we are saying change in y and delta t there. So you're able to fill that table with the given information, and then you come to the data sheet with the given information. You are able to choose the correct formula, then you substitute, then you use your calculator to write the correct answer with the correct SI unit and with correct direction for vectors. So I've emphasized that. Let's look at questions that have to do with this vertical projectile motion. Very much important. We are saying here a person dives from a high platform into a pool. At which one of the position A, B, C, or D will the magnitude of his momentum be a maximum? You see, when you look at this question, you can say, these are momentum questions. But if you look at the science behind it, the question is not necessarily asking you momentum. It's asking you velocity to say, okay, let's compare, because you know momentum, we said, is the product of mass of an object and its velocity. So if the mass of this person is remaining the same, the only thing that is changing the momentum of the person is the velocity. So we are still focusing on the velocity to say, okay, at the point of launch, when he was diving, and then he went up to C, he stopped there. So we know that the velocity here, initial velocity, he had initial velocity, which was not zero, definitely, and then that velocity decreased until it reaches point C there at the maximum height where velocity was zero. So velocity was 0 meters per second there. But now the velocity starts to increase when he comes back where he started to dive there. We talk about velocity symmetry. So we're simply saying that the velocity which they launched himself there is the same velocity we'll have when it comes straight to that velocity symmetry. And if now from this point D, the velocity will be more than the initial velocity that is started at D. So the velocity increases. So as the object, as it's moving down towards water, the velocity is increasing. And the velocity is maximum at A. Just before it reaches the water, the velocity will be maximum. And when velocity is maximum, we'll have maximum momentum. Hence, we are saying at point A, that's where we'll have maximum momentum there, which is option number A. So you are able to see that with that information, because what we are doing, we want you to have problem solving skills. That's what we are doing here. We don't want you to claim a problem. We want you to solve any other problem based on the problems that you have solved or problems that you are aware of. So the main focus is on the skill so that you are able to apply that skill come the exam tomorrow. Now we are saying a ball is released. Already as a science learner, you know that a ball is already released. You know that it is from what? Rest. Initial velocity is 0. So even before I ask you any other question, you know the meaning of that. It means that the graph must start from 0. The initial velocity was 0 because the ball was released. And then we're saying from a certain height above the floor and bounces off the floor several times. Ignore the effects of air resistance. You know the meaning of that. Now we are saying which one of the following velocity time graphs best represent the motion of the ball. So now if you look, we are looking for velocity time graph, which are usually straight line graphs. So you are able to see that. Okay, this one, it starts from 0. Okay, the ball was released, so the initial velocity must be 0. This one starts from 0, that one starts from 0. So this one, you see that this one is out because it's not starting from 0. The velocity there is not 0, so it's out because the ball was released. But the other important part is that the ball was bouncing. And you know, as the ball bounces, that's how we show the ball that is a bouncing ball with those dotted lines. It's showing you that the ball was bouncing. So you can see that the velocity time graph that starts from 0 and shows the bouncing ball is C there. So C becomes your answer. So you are able to respond to such questions. And if we were to look at the bouncing ball, again, in terms of this graph, you will see that we are saying a ball is thrown vertically downwards from the top of the building and bounces a few times as it hits the ground. The velocity time graph below describes the motion of the ball from time it is thrown up to the certain time t. Analyze the graph, have an understanding. What matters to us here, it is the skill that we must have. What are we saying? We are saying now, if we look at this type of graph, if we were to say the y-axis here, we're having velocity, the x-axis, we're having time. So if we were to say v times t, if you multiply these two, they must be able to give you the area under this graph. And if you check, the formula v times t will give you displacement, which is your delta x, because we know that velocity is the rate of change in displacement, v like that. So there you are able to cross multiply there, and then you see that delta x equals to vt. What are we saying? We're saying have that skill to say, when I multiply the y-axis and the x-axis, I must be able to go to the data sheet and check which formula will I be able to, what will I be determining. So you are able to know that this graph, it will give definitely give you that, which is the area under that graph. But if I say change in y over change in time, I'm now talking about gradient. You are able to see that, oh, even your maths, you say gradient is y2 minus y1 over x2 minus x1, which means now change in y over change in x. So you are able to see that change in v over change in t will give you the gradient. And you know that change in v over change in time, the rate of change in velocity, that is acceleration. So you know that the gradient of this graph will give you acceleration. So have those skills as you are dealing with graphs, and then whatever the question you come with, you will have that in your mind. But don't forget, this ball had initial velocity of 10 meters per second, this object, and as it is going down, you can see that its velocity increases to 29.6. Then it bounces. Immediately it hits the ground. You can see that it spends some time on the ground between 2 and 2.2. So that is about 0.2 seconds on the ground. It's important that you look at that to say now it doesn't immediately go up. It first spends 0.2 seconds on the ground there, and then you can see now it leaves the ground now with that velocity of, if you check here, you can see that velocity x, which is your 27, and then it's able to move, and it bounces again, it spends some time, and then you can check the 8 minus 7.71. You can find out the time that it used on the ground there, and then you can see that at the end of the day, by the end of what is happening, you can see that the ball is there where velocity is 0. So it has reached that point where final velocity is 0. Now let's look at the questions. Write down the speed with which the ball is thrown downward. So you are able to interpret the graph and say, this question is asking for initial speed, which is 10 meters per second. So you are able to answer that particular question. And then the other question is saying all parts of the graph have the same gradient. You see the issue of gradient that I've told you about? Very much important. What is gradient? We said change in y, which in this case change in velocity over change in time. The rate of change in velocity. What is that? Is acceleration. What is the acceleration for vertical projectile motion? We said our acceleration is equals to gravitational acceleration, which is constant, which is 9.8 meters per second squared downwards. So you are able to have that knowledge, and you are able to answer that. The answer there will be the gradient of the velocity time graph is equal to the acceleration, and the acceleration is constant and equal to the acceleration due to gravity, which is 9.8 meters per second squared. So you're able to get your marks for answering that particular questions. I hope you got that, and as a skill, you will be able to answer other related questions. Now, we have question 3.3 that said, calculate the height from which the ball is thrown. Calculate the height from which the ball is thrown. Important again, data collection. So, okay, the ball was thrown. What do we know about this ball? When it was thrown, the initial velocity was 10. When it hits the ground during first bounce, the velocity there was 29.6. We know g is 9.8 meters per second squared. We even know the time there. The time is 2 seconds, the time of the first bound. So you have about 4 variables. You are asked of the 5th variable. So be able to do your data collection, and immediately after you have done your data collection, you are able to answer your question. Data collection first. What is initial velocity? 10. The final 29.6. The acceleration 9.8 meters per second squared. And then we were asked for delta y. And then we had our time as 2 seconds there. So with no any wasting of time, you will definitely go to the data sheet and look for the formula that will be able to give you the height there, your delta y. And then you can see that this one, it doesn't have delta y, doesn't have the height. So it cannot help us to answer the question. You will definitely go to the other formulas and you'll choose the correct one, which is the change in y is vi delta t plus half at squared. Remember already we have agreed that we have time, we have gravitational acceleration, time we said is 2 seconds, we have initial velocity as 10. So definitely that one is going to solve our problem. And with no wasting of time, you substitute in your formula, you get your answer, and you are able to write your final answer as the height of the building is 39.6 meters. So you are able to do that calculation and you got your 3 marks, one for each of those formula, substitution, and final answer. And then you got your 3 marks. So we are hoping that you will continue to deal with it this way. And then we're saying determine time t shown on the graph. So you are able as well to do the calculation of the time. Final velocity is equals to, now remember you are having your 8 here from 8 to t. So that is, we want now the time. You'll first calculate this time, which is the time from 8 to t, and then you must add this time to the 8 to get the time t. Remember time t is increasing from 0 to t there. So it must be 8 plus the time between 8 and t. So if you are using this, you would know that, okay, already here the t is at 0, the final velocity there will be 0. At least you are having data that you are dealing with. You know your g as well is 9.8, and then you are able to do your substitution. And then you have seen that you started here with your velocity there from the graph is negative 25 from there. And then you just substitute negative 25, your g delta t, final velocity is 0. You are able to do your substitution. And then with no waste of time, you are able now to find your t. But you can't leave your t as 2.55 seconds. It must be 2.55 seconds, which is the time from 8 to t. You must add the 8 to get the total time. That is very much important. That is where you will get your final mark, which is 10.55 seconds. So I hope that helps you as you prepare. Now, on the question of linear momentum and impulse, here there are a lot of definitions that we expect you to know them. Definitions it's a must that when you go to your exam, you know all these definitions. And we are saying the very first one, which is your momentum, define momentum, which you are saying datasheet will help you, the product of mass and velocity of an object. You will definitely do that. And we are saying this momentum is a vector, and we are saying it's measured in kilograms meters per second. And then you know that Newton's second law in terms of momentum as well. F net equals to the rate of change in momentum. So you got to definitely know that one. The impulse as well, F net delta t. F net delta t equals to change in momentum. That is, your impulse is this one. Please, I always emphasize this to say impulse is the product of the net force and the time that that net force is acting on the object. And then always know that you're going to define impulse using F net delta t. You don't say impulse is the change in momentum. We will mark you correct when you say impulse is the product of the net force and the time taken when that force is acting on that particular object. And then we are saying now here, the isolated system, we're saying that there are no external forces that are acting on this system. Hence, we refer to that system as being isolated system. You can't write exams without having that. I always emphasize that any question that says principle of conservation, principle of conservation of linear momentum. You cannot forget that. As long as it's a principle of conservation of anything, you know that the main thing you're going to do is to say total what? Linear momentum in an isolated system is conserved. So always that's what you are doing. Principle of conservation of mechanical energy, total mechanical energy in an isolated system is conserved. Principle of conservation of linear momentum, total linear momentum of or in an isolated system is conserved. Please always don't get that mark wrong. Always collect any mark that says write down the principle of conservation. And you must know the difference between elastic and inelastic collision. And here we are emphasizing that for elastic collision, we are saying both momentum and kinetic and total kinetic energy is so both of them, the momentum and kinetic energy are conserved. So both of them. But in an inelastic collision, only momentum is conserved. Kinetic energy is not conserved. What do we mean by that? We're saying total kinetic energy before is equal to total kinetic energy after. So if the initial kinetic, the total kinetic energy before is equal to total kinetic energy after, we say the collision is elastic. But if it's not, we'll say the collision is inelastic. Like in our last graph, we have seen where we had our initial velocity was 10, the object went to hit the ground with 29.6, but you saw at point T, the velocity there was now 25, minus 25. If you remember the question that we just did now, then you will see that the velocity is decreasing, and by so doing, because our object was spending some time on the ground there, you can see that that would be a good example of an inelastic collision. But in an elastic collision, we're saying both kinetic energy and momentum are conserved. And then in an inelastic, only momentum is conserved, but kinetic energy is not conserved. And when you say show that through a calculation, you cannot write this first. No, you must first calculate the total kinetic energy before, and then you calculate the total kinetic energy after. Then you compare them. If they are equal, you will say it's an elastic collision. If they are not equal, you will say it's an inelastic collision. Please don't make a mistake of concluding when you start with the calculation, because immediately when you say like this, you are saying the collision is elastic. Then what's the use of calculating? We're saying calculate first total kinetic energy before, calculate the total kinetic energy after, compare them. If they are equal, you will say it's an elastic collision. If they are not equal, you will say the collision is inelastic. I hope you have that and you will apply it and all will go well. I've already talked to this, the important concepts. In terms of tips for linear momentum and impulse, we're saying always read the scenario carefully and underline keywords. Remember that velocity, momentum, change in momentum, and the force, they are all vectors. And when we're dealing with vectors, magnitude and direction. Hence, we're saying you must always choose the positive direction. Which one is positive? Refer to the datasheet when carrying out all the calculations, and we are saying pay attention to mark allocation and remember the elasticity of collision to say is it elastic or inelastic, which is something that I've really have explained. I've explained that. So I'm hoping that information, as you carry it towards dealing with momentum questions, it will help you. Under work, energy, and power, I would like us to do some questions here that are based on work, energy, and power to ensure that you come tomorrow, you are able to do well in this topic. Now, this topic, you started it here from grade 10. In fact, from lower grades, you have been doing energy. You have been doing kinetic energy and gravitational potential energy. Now, the most important thing, you know now by now what is gravitational potential energy. We said this is the energy that the object has because of its position. And we said isolated system means there are no external forces that are acting on that particular system. External forces, we're talking about something like friction. So when we have no friction, we're talking about now isolated system. Remember, when it comes to mechanical energy, we apply it in an isolated system, in a frictionless surface, when there are no non-conservative forces. When we only have conservative forces, we'll apply this principle of mechanical energy, which is important that you have that. You have learned that kinetic energy is the energy of an object due to its motion. When the object is in motion, we talk about kinetic energy. And the law of conservation of energy, remember what we said, energy cannot be created nor be destroyed. It can only be transferred from one form to another. What is this thing that we refer to as mechanical energy? Mechanical energy, we're saying, is the sum. Mechanical energy is the sum of gravitational potential energy plus the kinetic energy. That sum we call mechanical energy. To say define mechanical energy, you know that it is the sum of the gravitational potential energy and the kinetic energy of an object. The principle of conservation of mechanical energy, remember, we've agreed that anything that says principle, you would simply say total. Total what? Mechanical energy, because we're talking about mechanical energy now. So this will be total mechanical energy in an isolated system. In an isolated system is conserved or remain constant. So you're just putting total there before mechanical energy. As long as you say principle of conservation, you just come and say total mechanical energy in an isolated system is conserved. So please collect all the marks that want you to state the principles of conservation. Now, we've talked last year final exam, we had a definition that said to the learners, define work done by a force. And that is the first thing in your exam guideline. It defines you the work done by a force, and it refers to the product of the force and the displacement in the direction of the displacement. And then the formula given is W F delta X cos theta. It helps you. Remember what when we're defining momentum, we said it's the product of mass and velocity of an object. When we're defining impulse, we said it's the product of the net force and the time taken when that force was acting on that object. Even here, we're saying is the product of the force and what? And the displacement, and then in the direction of that particular displacement. So it's very much important that you have all these definitions. And the issue of positive and negative work done, very much important to say. You always look at the relationship between the force and delta X to say what is the relationship between these two. If the force and delta X are acting in the same direction, if they're all moving in the same direction, we're saying our cos is cos 0 degrees. Remember, cos 0 degrees is positive 1, which means positive work is done when the force and delta X are in the same direction. But now, where you have the force and delta X acting perpendicular to one another, the force is going upward, the object is going in that other direction. So that is, it forms the 90 degrees perpendicular. When they are perpendicular, we're saying F delta X cos 90 degrees. And you will know that cos 90, if you use your calculator, it will give you 0, which means no work is done when the force and the displacement delta X are at 90 degrees. So that is no work done there. But when the force, like friction, for example, it opposes the motion, it opposes where the object is going. So when we are having friction and delta X in opposite direction, we're saying our angle there is 180. So you're going to utilize definitely cos 180. And if you say cos 180, you'll get -1. Hence, negative work is done when the force and delta X are in opposite direction. So always those small things are the things that steal away marks from us. So ensure that you have that knowledge and you are able to apply it. And then we're saying the principle of conservation of energy, we talked about it. And then we're saying energy cannot, the total energy cannot be, is conserved, cannot be, the total energy of an isolated system is conserved. And then the issue of work energy theorem, the work energy theorem. from your data sheet, the work done by the net force there, we said is equals to the change in kinetic energy of the object. So you are able to know that work net equals to change in EK. That is your work energy theorem. Now, other formulas that these days you get many questions on, you can't go to the exam room without knowing any of these definitions, especially these ones, conservative and non-conservative force. The only thing you have to first know what are the conservative forces. So you got to know that the conservative force here, we're talking about forces like Fg. The example of non-conservative force, we're talking about friction. And we're saying conservative forces, we're saying now, if we're talking about the work done by conservative force, we're saying the work done in moving an object from one point to another is independent of the path taken. So you must know that for conservative force, the work done in moving an object from one point to another is independent of the path taken. But for non-conservative force, we're saying now these ones, it is the where we have friction. We're saying the work done in moving an object from one point to another is dependent on the path taken. So conservatives are independent. We're talking about Fg there. Non-conservatives, they are dependent on the path taken. And then lastly, you must know power. Remember, in terms of power, we are saying power is the rate at which work is done. From the data sheet, as I've shown you, you were able to see that power is the rate at which work is done. And then power is the rate at which energy is transferred. So sometimes you can define in terms of energy there. And then the other thing about power that you must know is that we talk about average power when we are having the force multiplied by constant velocity. When we have V average, we can use that formula of P average equals to F average. Very important that you have the knowledge of all those formulas and the SI units that we use. For example, for power, we are using the watt as the SI unit. So as you do calculations, you will have that. I've already explained this. The positive work done to say the force and delta x are in the same direction. So cos 0, positive work is done. But if the force and delta x are having an angle of 90 degrees, we said no work is done. And then we talked about the negative work done there where the force and the displacement are in opposite directions there. So you are able to do that, and then without wasting time, we are able to move. Now, when you are solving problems that are based on work, energy, and power, we are saying always draw a free body or force diagram. Always draw a free body or force diagram and identify the forces that are doing positive and negative work. So it's very important that that free body diagram is there to say how many forces are involved here, how many forces are doing work, and if these forces are doing work, are they doing positive work? Are they doing negative work? So that when you say work net, you are able to add all of them together, the positive work done, the negative, then you're able to get your work net, and then you are able to get your answers. And then we're saying when you have the data, go to the data sheet and identify the correct formula that you will use. And we're saying the angle theta is between the force and displacement. I've emphasized this to say always look at the force between the angle between force and delta x. When it's 0, they are going to the same side, cos 0 degrees. When the angle is 180 for friction, for example, we said cos 180 degrees. And then we said when they are perpendicular, the force and delta x, no work is done. So always take that into consideration. And we are saying ensure that all quantities substituted in the formula are in SI unit. I don't know whether you get that. What do we mean by that statement? We mean that if you are given mass in grams, you cannot use it for calculations. Remember, mass must be in kilograms, which means grams you divide by 1,000 to convert them to kilograms. We can give you velocity in kilometers per hour. Remember, kilometers per hour, you must first convert the kilometers per hour to meters per second. So please always have that knowledge there to say, how do I convert from one to another? Then you won't have a problem, then you will be able to get what you are supposed to get. and your answer will be fine. So always use the correct SI unit. And the data sheet that we're having for this question, work is given there. You can see the definition of work, you can see the definition of power, you can see the definition of mechanical energy. We said it's the sum of kinetic energy and potential energy. When you say the principle, all you are bringing now is that the total mechanical energy before collision, the total mechanical energy is conserved in an isolated system. So you can see the importance of that data sheet that I'm always referring to, because we are saying leave no question unanswered that says calculate, because your responsibility is to collect the data, go to the data sheet, choose the correct formula, substitute on that formula, get the correct answer with the correct SI unit and direction. Now, let's look at an activity that involves work, energy, and power. This one is saying the diagram below shows a track ABC. The curve section, so we're having the curve section, which is frictionless. So you can see from A to B, no friction. Remember, what does that mean? No friction means we're talking about conservative forces, which means the only force that is acting there is the force of gravity. And we can apply the principle of conservation of mechanical energy, which means mechanical energy at A will be equals to mechanical energy at B, because that is conservative forces that are acting. Immediately when you say BC is rough, so we're saying no, you can't now apply, you cannot use the mechanical energy principle. You can use the work done by non-conservative force, or you can just use work net equals to change in kinetic energy. So I'm saying in terms of the formulas, you got to know that immediately when you have a rough surface, that's when you can use work done by non-conservative force equals to change in EK plus EP. But as for work net equals to change in EK, you can use it there even on the AP side. You can be able to use work net equals to change in kinetic energy. But this one, work done by non-conservative force, will only be applicable when we have friction. It means between B and C. And mechanical energy, the principle of conservation of mechanical energy will be applicable in a frictionless surface when we have conservative forces. So it's very much important to know that we have conservative forces, we can use the mechanical energy principle. We have non-conservative force, we can use the work done by the non-conservative force to do our calculations. I hope that helps you. And then we're saying an object of mass 10 kg released. So the fact that we're saying is released, so it means initial velocity at A is 0, which means we have maximum gravitational potential energy, which is our mgh. But as the ball now is released, as the object now is moving down, you can see that gravitational potential energy is converted to kinetic energy. Very much important as well. And then they say it comes to rest at point C. It comes to rest, so it stops there at point C. So it was released, initial velocity was 0, and at point C again, it comes to rest, it stops again. So we know the velocity at A and the velocity at C. The velocity that we don't know is the velocity at B. So that will help you as you answer the question. State the principle of conservation of mechanical energy. Already we talked about this, to say all you will do is to say the total mechanical energy in an isolated system is conserved. And then after you have done that, you know that now calculations are coming. Calculations are coming. Is mechanical energy conserved as the object moves from A to C? What a nice question. Is mechanical energy conserved? You know that mechanical energy is conserved from A to B because that is a frictionless. But from B to C is not conserved. Hence, you will say from A to C, mechanical energy is not conserved. So your answer there will be no. Mechanical energy is not conserved. Now, going forward for 6 marks, this question says using energy principles only. So you know, in terms of energy principle, we talked about mechanical energy, we talked about the work net equals to change in kinetic energy, we talked about work done by the non-conservative force, which is equal to change in EK plus change in P. So they're saying these are the principles that you can work around. Now they're saying calculate the magnitude of the frictional force exerted on the object as it moves along BC. Very much important. However, you got to acknowledge that you know the final velocity there at C is 0, but you don't know the velocity at B. So it's important that you first know the velocity at B so that you are able to do your calculation now with confidence, knowing that at B, this is the velocity, initial velocity, at C, this is the final velocity. So as you plan to answer this question, always have that in mind to say, I must ensure I get the velocity at B so that I'm able to move forward. So in terms of the formulas, you can choose the formula work net equals to change in kinetic energy, and then you can now derive that particular formula in terms of work net equals to that. You know that from A to B here, you want here the velocity there at B. So there you know that the only force is Fg, hence you will have mg delta H cos theta, and because it's moving in the same direction, it will be cos 0 degrees. So you're able to see how the substitution comes about, and with no wasting of time, you do your substitution. Your mg is 10, your m is 10, the mass of the object is 10, and then the g is 9,8. The height is given here, it is 4, and then cos 0, and then that is half 10, which is your mass, and then the final velocity at B, we don't know, but we know the initial velocity was 0. So you're able to do your substituting there, and if you do that correctly, you're able to find the final velocity at B. And your final velocity at B is this one. But you must know that your ultimate goal is to be able to calculate the frictional force, the force here. But you needed this final velocity here because it becomes your initial velocity, hence you got it there. Now you can now go and use the principle. You can use the work done by the non-conservative force, or you can continue to use work net equals to change in kinetic energy to determine your friction, because the only force now along BC, that is 18, is the frictional force. So if you say work net equals to change in kinetic energy, you will substitute the frictional force there. The work done by friction is F delta X cos theta, and then you are able as well now to substitute and say our F is what we are looking for, but we know our delta X is 8 meters we are given, and we said friction opposes motion, so it will be cos 180, and this gives you half of 10, and then you are having now 0, which is V final is 0 here. V initial, we calculated it as 8,85, and then we are able to put it there, and then we are able to deal with it there. It's 8,85, just have 2 decimal places as you substitute there, and then your friction will be 48,95 newtons. So you were able to answer the question because you understood the principle behind it. So there are many ways that you will be doing. I thought this question would be more helpful because you can combine the principles of mechanical energy and the principles of when we're having non-conservative forces, because we had both of them there. Now, in terms of Doppler effect, the most important thing here under Doppler effect is the definition. The definition of Doppler effect, it is the Doppler effect equation. It is the application of Doppler effect. It is the question of redshift. So you see, I'm emphasizing this because these are the most important things that you cannot wake up in the morning to go and write without knowing. 1, define Doppler effect. 2, write down the formula for Doppler effect for towards away, whether it's the source moving or the listener moving. Remember, for our grade 12 syllabus, if the source is moving, the listener is stationary. If the listener is moving, the source is stationary. So you got to have that understanding that it's not all of them that are moving, and then you are able to do that. Now, you must be able to solve problems using the equation. The equation is given, and then you must be able to state application of Doppler effect. The issue of redshift, I talked about it. Here we're saying the universe is expanding. So all those are things that you must know about. But now, the first thing, which is now the definition of Doppler effect. Now, listen to me carefully. This one are marks that you must collect. We are saying now Doppler effect is the change. So we are putting change here. Is the change in frequency of the source. Change in frequency of the source detected by the listener. Change in frequency of the source detected by the listener. Why is that the case? Because the source and the listener have different velocities. Remember, I said the other one is moving, the other one is stationary. So the source and the listener have different velocities. That is the first reason. So we're saying what is Doppler effect? Is the change in the frequency of the source detected by the listener because the source and the listener have different velocities. Where now? Where now? Now we talk to the last part of the definition now. We are saying now we are having a relative to the medium of sound propagation. Can we package it together? We are saying Doppler effect is the change in the frequency of the source detected by the listener because the source and the listener have different velocities relative to medium of sound propagation. So we're saying this V depends on the medium. To say, is it on air? If it's on air, we know that the velocity of the speed of sound will be 340. 340 between 332 and 343 because the value can change between those. So always have that in your mind to say it is the change in the frequency of the sound detected by the listener because the source and the listener have different velocities relative to the sound, to the medium of sound propagation. Well packaged. You will always copy this formula as it appears in the datasheet before you do anything or any change. Now, the question would be about a moving source approaching. When the source is approaching, you are expecting that now the listener now, because there is approaching, will get more. So it means it's plus over minus. So you always have VL over VS multiplied by F. So that's what we are saying. A moving source is approaching a stationary listener, which means for the listener there, you will write 0. But don't forget, approaching, we are saying is plus over minus. Important. Plus over minus for approaching. But because the listener is stationary, it will be V plus 0, which is V over VS. But now when we say a moving source moving away from a stationary listener, which means now we'll have the same formula, V plus 0, which is V, but now because it's away, it's minus over plus. So the denominator there, we're having a plus, so that we have it's away. So we want the listener to detect a decreasing a pitch in terms of sound. Hence, we're saying that for away is minus over plus. And then we're saying this listener is stationary, so it will be 0 there. A moving listener, same here. We are saying, okay, a moving listener is equals to V approaching towards, it will be plus VL over V. Why V? Because the VS is stationary now. So always you will change your formula based on that. But you know that approaching is plus over minus. And going away or approaching or moving away, we are saying it is now minus over plus. Minus over plus. So you will have FL equals to V minus VL over V. And then you are able to do that. Don't write this as your formulas now. Don't write this as your formula. Your formulas is the one that appears in the data sheet. From there, you check which one is stationary. The stationary one, you put a 0. Towards is plus over minus. Away is minus over plus. Then you are able to do your calculations. And we are saying, don't forget the wave equation, because it's always reminding you the relationship between wavelength and frequency. Because we are saying as the wavelength increases, the frequency decreases. So that relationship, according to this formula, very much important. And some of the time you'll be asked as well to use that formula for your calculation. And we are saying a higher frequency sound has a higher pitch. So frequency and pitch, they go together. So if we have higher frequency, we have a higher pitch. And you know that if we have higher frequency, it means we have lower wavelength. So which means lower wavelength. When you say higher frequency, you are saying lower wavelength. Always relate them like that. And when you have a higher frequency, you have higher pitch. So the pitch moves together. When frequency increases, the pitch of sound increases. However, when frequency decreases, the pitch decreases. When wavelength increases, the frequency decreases. So always have that relationship, and you will be able to answer questions. Now, without wasting time, let's go to the activity that is based on Doppler effect. We're saying an ambulance moves away from a stationary listener with a constant velocity of 25 meters per second. The ambulance siren emits sound waves at a frequency of 550 hertz. The listener detects the frequency of these sound waves to be 512 hertz. Ignore the effects of wind. So data collection is everything. Please do your data collection. Without it, there is nothing you can do. State the Doppler effect. Go to the formula. You said it's a change in the frequency of sound detected by the listener. Why? Why is it so? Because the source and the listener have different velocities relative to the medium of sound propagation. Your 2 marks, you go with it there. You got it, you are ready, you are smiling. You are saying, use the given information to calculate the speed of sound in air. A science learner would be laughing alone here to say the speed of sound in air, we know it ranges between 332 and 343. Then you know that if you get 340, you get 341, you are happy. That is the speed of sound in air. So when you have a question like that, the most important thing, you will identify the formula, but based on data collection. To say, well, given the frequency of the listener detected by the listener, it was 512. We've given that the listener is stationary, it is 0. Stationary listener, it means VL is 0. We're given that the frequency of the frequency of the source is 550 hertz. We're given that the speed of sound is 25 meters per second, constant velocity of sound. It was moving with 25 meters per second, and we want V, the constant V. So you're able to write the formula from the data sheet. Write the formula from the data sheet, this one. Always start with that one, the original. And then you see that the source was stationary, so you can just write V over V plus Vs times Fs. And then you start to the rest now. So frequency of the listener, 1 mark. Frequency of the source, 550. The V over V plus 25, to know that stationary with a constant, the ambulance siren emits sound waves, the listener detects the frequency. Remember, it was producing 550. The source is 550, but the listener is getting 512. So you see already that this is away because there is decrease in the frequency detected by the listener. So you will know that this is away, which is minus over plus. So you're expecting a plus here at the denominator, as we did there. And then look at the number of marks that you are able to collect. So please do this and collect your marks with no waste of time. And you got 343, and you are having the range there between 330, 332, 343 in terms of you rounding offs and all that. Now, activity 6.1.3, it said an ambulance moves away from a stationary, it's the same statement. We're saying if the ambulance moves away from the stationary listener with a constant velocity, which is greater than 25. So we're saying no, if now the speed that the ambulance is moving with is more than 25, but it remains constant, maybe 30 meters per second, for example, how will each of the following change? You must choose from increases, decreases, remain the same. I know with learners, you say increases, decreases, remain the same. They'll come and say increase, but there's no increase here. There's increases, decreases, remain the same. Always pay attention to those small things. We don't usually penalize you, but it's good that you write the right signs. What will be the speed of sound in air? What will they? How will each of the following change the speed of sound in air? The speed of sound in air is constant. It's constant. It's not dependent on on the speed of the source, because the ambulance or the source is moving with the higher speed. Now the speed of sound in air changes. No, it remains constant. Hence, we're saying it's around 340 meters per second. So it will remain the same definitely. And then the frequency of the sound waves emitted by the siren. So the frequency of the sound waves emitted by the siren, remember, the siren cannot depend on the speed. The sound source is the source that is having. So it will remain the same. The frequency of the sound waves detected by the listener, definitely it's moving away. It must decrease because it's moving away. Now, with no waste of time, let's move. The spectrum of a distant star when viewed from the Earth is redshifted. It's good that we talk about the redshift, because when we talk about redshift, we're talking about increasing wavelength. We're saying longer wavelength. Longer wavelength means shorter frequency, and that means we are having red shift, which means the spectral lines are moving towards the red end of the spectrum. So it's important to have that in your mind, to say, is the star moving away from or towards the Earth? Remember, redshift, we're talking about longer wavelength, which means the star must be moving away from. And then when you ask learners, is the star moving away from or towards the Earth, the learner will say away. But the question says away from or towards. So it's important. The answer there, it must say away. It's moving away from. And then use the Doppler effect to explain the answer to 6.2.1, which is what I already said. To say, when you talk about redshift, we're talking about longer wavelength. We're talking about now your decreased your frequency being shorter frequency. And then definitely because you are having longer wavelength, we are saying that the spectral lines are moving towards the red end of the spectrum. So please have that, to say we have a lower frequency, a longer wavelength is detected, and we are saying the spectral lines are shifted to the red end of the spectrum. So that is what we call now, we're saying now the stars are moving away. We talk to the concept of expanding universe. So I hope this activity will help you as and when you prepare for this topic. Go and get everything that you are supposed to go in terms of this topic, and then do it. Now, our last two topics, as we quickly wrap up, we're saying electrostatics, electrocharges that are not moving, the principle of conservation of a charge. Remember, we said the total charge of an isolated system is conserved or are conserved. Coulomb's law. Coulomb's law. You simply come there. Coulomb's law. The electrostatic force of attraction or repulsion. The magnitude of the electrostatic force of attraction or repulsion is directly proportional to the magnitude of the product of the charges, and inversely proportional to the square of the distance between them. So with confidence, you must go to exam knowing Coulomb's law. We don't have many definitions in terms of this electrostatics, so we're expecting you to know all of them. Those three you can't go to the exam without. To say Coulomb's law, to say electric field. Remember, like a soccer field, we're saying electric field is a region in space where a charge will experience a force. And electric field at a point, we are saying take it from here, is the force per unit positive charge. Force per unit positive charge experienced in that point, at that point. So that is the electric field at a point. Please always have that, and always this will help you as you go to do questions. With no waste of time, let's look at an activity. We're given 2 point charges. Our point charges is X and Y. Our point charges is X and Y. They are held 0.03 meters apart, as shown in the diagram below. The charge, we're given a charge of negative 7.2 times 10 to the power of minus 9 coulombs, and for Y as well, we're given positive charge of 7.2 times 10 to the power of minus 7. Those are our charges. State Coulomb's law. So we are able to state Coulomb's law. We've stated it. The magnitude of the electrostatic force exerted by 1 point charge on another point charge is directly proportional to the product of the magnitude of the charges and inversely proportional to the square of the distance between them. Please go to exam knowing that one. Draw the net electric field pattern. Important. We're having a negative and a positive. So be able now to draw the electric field patterns. Remember, we are saying always look at yourself as somebody who's carrying a positive test charge. As you bring a positive test charge towards negative, obviously there will be attraction. Hence, we are saying the arrows must be towards negative because your positive test charge will always be attracted to the negative charge. But when you bring a positive test charge close to the positive, it must be repulsion. Definitely, the arrows from positive must be repelling this positive test charge that you are bringing. So if you have that in mind, you are able to draw this with no problem. And then we are saying the criteria for marking there, you have 1 mark for the correct shape, 1 mark for correct direction from Y to X, from positive to negative. The direction as well is 1 mark. Important. Correct shape, 1 mark. And lines must not cross. Immediately one of these 2 lines crosses, we're taking 1 mark away. And we're saying the lines must not touch. They must not touch one another. Please do it like that to get all your 3 marks. Now, on this one of 7.3, we were given 2 point charges x and y. Calculate the magnitude of the electrostatic force that y exerts on x. Important. It's just a straight calculation of between y and x. You will definitely write the formula F equals to k q y kx over r squared. You substitute, you get the final answer, and then you get your 3 marks. Please ensure that you are able to do this, and that is straightforward. I hope all of you are confident to do that. 7.4, a third point charge, that of the unknown position charge is position 0,01 as we're given, but the question is saying draw a labeled vector diagram, to show the direction of the electric fields. So you can be asked to draw a vector diagram. So, okay, how will it be? We're looking at EY and EZ, EY and EZ, because the question was about endpoint X. Remember, they said a third point charge. Z is a third point charge. So we've brought about the third point charge, which is Z there. Then you are able to see, okay, Z is positive, and then Z obviously will be attracted. It's moving, that is attracted to the negative, towards the negative. Even this one is attracted to that one. Hence, you see that EY to the left, EZ to the right. You can draw them like that. You can draw them like this. You can draw them like that. All of those 3. As long as we say draw a labeled vector diagram, that's how you'll go about doing that. I hope that helps you as you prepare for your exams. And then the last question here was, after we've added third point charge, we were saying calculate the magnitude of the resultant electric field at the point where X's position is 4,91 times 10 to the power of 5. Important there is times 10 to the power of 5 Newton per coulomb. So we're given E net, but we have to calculate the charge Z. So you know E net is when we add EZ and EY. When we add this one and this one, we can get our E net, and our E net is given there. So how do you do that? You substitute the, for Z is KQZ over R squared, for Y is KQ Y over R squared. So you're able to do your E net there. And then you substitute E net, you know the value of E net, it was given. You don't know the value of QZ. So you will substitute your K now, which is your constant, which is 9 times 10 to the power of 9. You will substitute your 0,01, your R there. And then you will go to the other formula. You will substitute your Q for Y, which is 7,2 times 10 to the power of minus 9. You will substitute your 0,03. But now this negative here is allocated a mark. Very much important. Remember, you are the one who have drawn the vector diagram. You said Y and Z were in opposite direction. Hence, we'll write the negative, and that negative will be given 1 mark. So you can see, you can collect as many marks as you want, and then you are able to determine Z. And these days we're having lots of questions that comes this way, where you have now to determine the charge. It's no longer the question of saying calculate E net, where you just do the 2, you add them together. We're now saying no, we can give you the E net, we give you the other charge, we don't give you another charge, then you have to determine the other charge. Very much important. That's the movement, that's how we are moving. So always have that in mind. Very last topic, electric circuits, electricity. Now we're saying EMF, you got to definitely know the definition of EMF. I know that in grade 10, you have defined potential difference as work done per unit positive charge. And I know that you know that this is energy. Work done is energy transferred. So you are able to have that understanding to say when you talk about EMF, we're talking about the maximum energy supplied by the battery per unit charge of per unit charge of a coulomb passing through it. So that's how you're going to define your EMF. It's the maximum energy supplied by the battery per unit positive charge passing through it. You are able to get your EMF. Please always have that. Remember, now we are emphasizing the importance of internal resistance. But before that, we are saying EMF, which is now your current R plus R. So you have that in mind, and you know that your EMF is equal to V external plus V internal. And then you know that is IR plus IR. And you know that you can take your R outside, which is R plus R. So please always have that, and you are able to move. Now, the other thing was saying you have done the experiment on the internal resistance. Remember the graph there that includes the internal resistance. You cannot go to the exam room without it. And we're reminding you the V external equals to EMF minus IR. You got to know that graph, the graph of V versus R versus I, we are saying that on your y-axis you have that, and then that will be your C, that will be your M, which is your R, your gradient, and then you have your current now in your x-axis. Your y equals to mx plus c. So you are able to see the relationship between that and that one. So at the end of the day, we are emphasizing that if you're doing that graph, they see where the graph is cut on the y-axis, that's when you are having your EMF, and your gradient is your internal resistance. And on your y-axis, you're having your V, and then on your x-axis, you're having your current. So it's very much important that you have done this experiment as well. And then we talk to the issue of Ohm's law, which we are taking from the data sheet. R equals to V over I. What are we saying? We just cross multiply there. We will get V equals to IR. We are saying that the potential difference across the conductor is directly proportional to the current, provided that the temperature remains constant. You can't go and write without this. All that is in this page is something that you have to know. And then you know the series and parallel circuits, the series resistors, the parallel resistors, and then the issue of power, which you said we can be able to calculate power as we have the data sheet. You will see we are able to do all of that. And that's what we are saying. To say your Ohm's law, you come here. But we are saying it must be about V, which are saying the potential difference across the conductor is directly proportional to the current, provided that the temperature remains constant. The EMF, I just defined it for you to say it is maximum energy supplied by the battery per unit positive charge, per unit charge passing through it. EMF, we are together. The formula for EMF is given there. And then we are saying when you have to calculate the R series or R parallel, you will definitely use these formulas. And we're emphasizing here to say, don't be in a hurry to use the R parallel equals to product over sum. Yeah, be in a hurry to first copy the formula that you are given, which is this one. Copy it as it is, then you can do the RP equals to what, and then you can do that. And then be able now to substitute the values and get. But this formula, you can use it when you have two resistors in parallel. But when there are more than two, it's better to just work with the formula that is provided there. And I've seen that majority of learners now, they want to say, they will copy the formula 1 over R parallel equals to 1 over R1 plus 1 over R2. Let's say you are having 3 resistors. Then the next step, they'll just say R parallel equals to, then 1 over, they substitute the values for R1, for R2, and for R3. After substituting them, they put that to the power of -1. And definitely they always get the correct answer. So I find this method being the simplest way of doing it. And I'm hoping that you are going to utilize that as well, and it will help you. When it comes to power, you will always look at what is given, and then you choose the formula based on the given information. So your data sheet is your friend. You must be moving together with the data sheet to say everywhere I go with the data sheet. I felt that I must finish with the question. The second diagram below shows a battery with an EMF of 12 volts and an internal resistance of 0.5 as given in the diagram there. And we're saying connected to the three resistors, a light bulb, a switch, an ammeter, and the connecting wires. We're saying the ammeter and the connecting wires have negligible resistance. Yes, the resistance must remain the same for us to be able to do what we are doing. And we are saying switch S is closed. So switch S is closed there. That's what it means. And then we are saying state Ohm's law. We talked about that to say the potential difference across the conductor is directly proportional to the current, provided the temperature remains constant. You must be able to get that 2 marks. You must be able to come back with it and get it, and then we are all happy. Now, as we continue the question 8.2, it says calculate there. So 8.2.1, we must calculate the total external resistance of the circuit. Please, learners, I'm pleading with you, always underline the keyword is external resistance. It's not just total resistance. It's for the external circuit. Which circuit is the external circuit? Is the one outside these dotted lines there. Is the external circuit. So we're saying find the resistance outside in the external circuit. The internal circuit is this one with R of 0.5. We refer to that as internal circuit. But the external circuit is the one outside of that, which means we are saying come here, calculate the total resistance. And analyze the equation, have an understanding. We have a bulb there, a light bulb of 10 ohms, and we are having a 10 ohm and another 10 ohm, which are in parallel. Please, learners, there are learners that makes a mistake and think that R3 is in parallel with the 10 ohm resistor. No, and a big no. R3 is in parallel with the sum of 10 ohm and the parallel connection. All these, they are in parallel with 15 ohm resistor, which is R3. So for us to deal with this question, first get rid of the parallel there, to say, let me deal with the R1 and R2 so that I can be able to know now that, okay, can I use a product over sum? Definitely. I emphasized always start by writing the formula that appears in the data sheet. R1, 1 over R parallel equals to 1 over R1 plus 1 over R2. Remember, we're having two resistors in parallel, so you will go up to R2. And then immediately when you have done that, you can now use product over sum, which is R1 times R2 over R1 plus R2. Then you are able to do that, which is 10 times 10. I think it's 100 if my math is still correct. And then 10 plus 10 is 20. 100 over 20 is 5. So you will know that all these, they are going to give you 5 ohm. And if we add 5 and 10, you will get your 15 ohms. So we are having 15 and 15 in parallel. How good is that? Then it makes your life much easier, because you can even come and say this will be 15 times 15 over 15 plus 15, product over sum. Then you can be able to get the total resistance there, which is what this question is asking about. So learners, do this, and then you are able to do that with the product over sum. It works, and then you are able to say 15 times 15 over 15 plus 15, it gives you 7.5 as your R parallel. Then you got your R parallel is 7.5, which is the total external resistance of the circuit. So when you have done that, we are saying what will be the reading on the ammeter A1. So now we want to know the current now across this one. Say, what do we have? We have everything. You are having the EMF, which is 12. You want I, but you know R. R you said is 7.5. because the formula said R plus R, isn't it? So you know that EMF, you know it is 12. I is what you are looking for. R, you said for external is 7,5. You just calculated. Small r, which is the internal resistance, is 0,5. So you can substitute all of them and you calculate your current and you are able to get your 3 marks. And then that's how you go about it. And then you substitute your 12, you substitute your 7,5 plus 0,5, and that gives you 8. And if you check, 12 over 8 gives you 1,5 amperes. Then you got your 3 marks. Or you can say R total. Remember, R total is the R for external plus the R internal. If you add all those, they give you 8. And then you get 8 equals to 12 over I. You divide by 8 both sides, and then you make I subject of the formula. That is, your I is still 1,5. So whether you use that option 1 or option 2, still you are able to answer that particular question. Calculate the power dissipated by resistor R3. So now we are specific here to say we want this one. Now, don't forget, Leonard, you said the total current there is 1,5 amperes. And you know that our current flows, we say conventional current. Our current flows from positive to negative, meaning that our current is flowing this way. When it comes there is a branch, so the current must split. But because the resistance is equal, the current will split equally here, which means the 1,5 will be divided by 2. So you will get 0,75 amperes to this 15 ohm and another 0,75 to this 15 ohm. And the question is about this one, R3. So for R3, you know the current is 0,75. You know the R is 15. You go and look for the formula that has both I and R. And that formula is P equals to I squared R. So you're able to use that formula because you have I, which is 0,75. When it's split there, half goes there, half goes there. And let us always, how do I know the split? Say, the split is always known when you use the formula I equals to V over R. Immediately when you take the potential difference, the external, the potential difference there, which is your external voltage. When you take that external voltage, you divide it by the R there, it will always give you the current there and the current there, and it will definitely give you the 0,75. But in this case, because the two are equal, it's easy for you to understand the split. But sometimes you'll find that the resistance on the parallel are not the same. But what you understand is that if we have higher resistance, we'll have less current passing through it. So you're able to see that the resistance is the same, 15 and 15, which means 1,5 will be split equally. And then you split your 1,5 there, and you get 0,75. The squared times R. R is what? 15. And then you simply use your calculator and you get your correct answer. So that is 0,75. I mean 0,75 amperes. 0,75 amperes, that is your current, and then you substitute your 0,75 times 15 ohms times 15 ohms, and then you are able to get 8,44 watts, and you are cruising nicely and you are enjoying electricity, because this is the topic that if you have practiced enough, you will be able to answer as many questions as possible. Now, there are these questions that needs you to do the explanation. So I feel that it's important that when we conclude the lesson, we conclude with such, because learners lose a lot of marks here. Now, the question here is, if the resistance of the light bulb remains constant, 10 ohms, how will the brightness of the light bulb be affected? Choose from increases, decreases, or remain the same. What has happened, learners? Switch S is now opened. What does that mean? It means that now when switch N is opened, it means this one has been removed. Remember the total resistance. We calculated it. We said it's 15 times 15 over 15 plus 15, if you remember. And we said the total resistance for external circuit is 7,5 ohms. We're together when we're doing that calculation. Now, immediately when you open the switch, this 15 is gone, but immediately the total resistance now of external is this 15. So which means now that the resistance is double, the resistance is increasing. So we agree that when you open the switch, the resistance increases. So the resistance will increase. And then what happens now, because the resistance has increased, now I know you very well. You know that R equals to V over I. When the resistance increases, the total current will decrease. Interesting. But now the question is about the brightness of this light bulb. What is going to happen? Remember, when the current decreases, come here to the internal resistance and say, to get V internal, I am saying IR. So because IR, small letter R, because I is decreasing, which means the V internal is decreasing because it's dependent on the current. So if V internal decreases, it means more voltage will go out here because only less is lost inside. In fact, I don't want to use lost because I always believe energy cannot be created nor be destroyed. So I would like to say the voltage is left internally, is used internally inside that particular cell, or is transformed to heat or any other type of energy. So we're saying V internal now decreases. And if V internal decreases, it means V external increases. More of the V of potential difference will go out, because here when you decrease current, less voltage will go out. So there is more voltage that is coming here, which means the brightness now will do what? Will increase. So the brightness will increase. And question 8.3.2 says explain. So you're going to go through what I went through to say, okay, we have increased the resistance. And when we increase the resistance, the total current will decrease, which is what this statement is saying here, to say the total resistance of the circuit increases. This is what I said. And the total current in the circuit decreases. So what happens? The V internal or internal volts decreases because of the I decreases. The R remains 0.5, but the I decreases, the V internal decreases. When that happens, V external will increase. So when the V internal increases, we are saying there will be more power output that is coming out because we've increased the V, and therefore the brightness will increase. So I want you to always have this in your mind and analyze the question like this, and then you will do and enjoy electricity. Now, I want to conclude by giving you this exam tip to say time management is very much important. Don't spend too long on one question. Move on and return later if needed. Remember, I said show all steps. Even if you are unsure, write something logical. Marks are often awarded for method and steps that you have done. Stay calm and confident. You have studied. Trust your preparation. Remember, always when you are having data with you, always formula, substitution, answer with correct SI unit. If you are dealing with vectors, remember always the direction. Don't leave any multiple choice question unanswered. Don't leave any calculation question unanswered, because in physical science, when you say calculate, we are asking for a skill. The skill to identify the formula, to substitute, to write the correct answer with the correct SI unit, and to give the correct direction if you are dealing with vectors. In conclusion, I'm saying physics is not about memorizing. It is about understanding how the world works. Trust your reasoning and stay calm under pressure. Thank you. Thank you very much. I want to say the preview of the next lesson. We will meet just in time tomorrow, the 13th of June 2025, from 2:30 to 4 o'clock, revising paper 2 with more focus on stoichiometric calculations that gives our learners problem. We are hoping to see you then. Thank you very much. With these words of Albert Einstein, who said, anyone who has never made a mistake has never tried anything new. Keep on trying and write well your exam. Thank you very much.